have 4 very simple parts. I think they have been cut to do deburring tests. We have aluminum, some stainless steel, some thinner stainless steel. This is all in the gauge range. This is like an eighth of an inch. And then we have here something that is really odd. I think it is plated carbon steel, galvanized, galvannealed. And all these parts have been cut on a plasma machine, which have, even though the material is very thin, make some significant dross other than the aluminum. So we're going to start with the aluminum. The setting is very simple. This is 8-inch material. We have an aggressive block on there. This has very light dross. The aluminum is very soft. It has dross. And we are simply going to run that at about 4 feet a minute, even with the dross. At a very low pressure for the aluminum, only about 3 millimeter into the material, and we'll see what that does. If that's enough. If not, we will give it a little bit more pressure and we will reduce to 3 feet a minute. Unfortunately, we only have one sample for each material specimen, so we can't try different things. But as you can see here, so this comes out pretty clean, right? Well rounded. We could even do a little bit less. And for the non-burr side, we're going to do exactly that. We're going to take the pressure up by about 40,000. So now we are not in the conveyor belt at all. So this would run wear-free for the conveyor. And so especially on the non-burr side, we'll get a very, very, very good result. Again, 4 feet a minute and 4 feet a minute with a part like this, before we can, per side, you can run over 1,000 parts per hour. And you see the results here also extremely nice, good edge rounding. This will be a super nice paint quality. Moving on to the next part. So here we have a stainless steel part. It looks like 14 gauge. With this machine, I don't even need to go too far in it. So I'm going to come down 2 millimeters, which means that we are again in the conveyor belt. And the pressure roller is rapid, and I'm going to bring the speed all the way down to about 18 inches a minute. Really super, super slow to see if I can remove that dross that is on the part right now. And I can show you here on this similar material, stainless steel. You can see here where the cut starts in each of the holes is how much the outside edge looks pretty good. The question is, will it clean up this? And it does not. So what you see here, you see a good radius on the outside edges of the part where we can be more aggressive. It's a little bit jagged, but that's the cut. You can see, I don't know if you can see that in the picture, but we have a real angle here on that cut edge. And wherever the cut was clean around the hole, we have a good radius, but those little bubbles at the entry, it doesn't take that. So now we're going to do the reverse side where we didn't have that and see what that was. So those bubbles, while this is running here very slow, those bubbles we need to address on a white belt sander to remove the excess material that protrudes up. Of course, that is going to leave you with a sharp edge because you equally remove material from the surface, like a surface grinder, and that gives a secondary burr and a very sharp edge. Would be what you do for a tool if you wanted to sharpen. For that, we also going to have to grab some calipers so that we so this is really slow now. We're going to have to grab some calipers so that we can figure out what the actual thickness of the part is. So here you see on the back side, just the Dross belt machine with the red ceramic blocks gets you a very, very nice result. But like I say, this is about 18 inches a minute. Still in a small part like this, it's still the same. So we're going to have the same issue here and here. Before we do this, let me try, this is going to be the same. This is, like I say, a coated material. If we run this through the white belt sander, we are going to remove this coating. So let me run it through the cross belt on this side first. Then we can run a little bit faster because sometimes we run that at about 2 minutes. Right? And if you want to cut it here for here we have the part, and you can still see the coated surface. That is all good. We have a little bit of a top burr here, but it's super nice and round and it'll paint great. I think this is totally acceptable. But for this side, again, these starts, they will not go away, especially this one, really tall. And then we have some on the corner here. This will not go away. So, what we need to do here, we need to turn this on. 1.5. I know how this machine sits because I've been using it before. We are going to go to 1.3. I'm going to turn the belt on. We are going to run important is that you have a nice speed from there. I'm going to run this in the diagonal. Not too much temperature, but now you can see all those protrusions are gone. Where they were, you have little holes here from the burnout in your radius. It's ran like this through the white belt. So to simulate combination machines, you have to run it in the same direction through the cross belt, and then you will see what kind of a pattern that makes for your paint grip afterwards. And now, of course, you can run this a little bit faster. You'll run that at 15 minutes, because once you have removed the drop, there's no reason to go super slow. All you need is consistent edge rounding. There's nothing sticking up, nothing extra that needs to be removed. Now let's remember also that we are doing this here right now with very aggressive 50 grit ceramic blocks, where also the Scotch-Brite has some in it. And when you get the part, you will notice basically that this was run on a white belt also, because you see the pattern on the surface. I'm not going to rerun this so that you can see how much there is on there. I could run that also through the white belt, but I think we're going to do that quickly on this machine with this part. This is 1.2 millimeter. So this is an 18 gauge part. See, we didn't hit it super hard. We have a little bit here, but I think the cross belt will easily take care of that. And I have to apologize. You see this can be totally avoided by setting the pressure rolls a little bit lighter, and actually also setting the machine a little bit lighter and going slower. So again, in the direction of this. And we are running at 3 feet a minute. And in the meantime, pieces per minute. That was 3 feet per minute. So, you see a little bit of discoloration here, but we still have a good deburred result. So this is white belt was number 1, and number 2 is Dross belt. Right? At 3 feet per minute. And that didn't run yet. We're gonna run this back again at 2 feet per minute. And actually, because it's on material, I think it comes down a little bit more. Right. So now we are going to be in the video double. The aluminum ran at 4 feet per minute. And it was cross belt only. Both sides. I think one side ran a little faster, a little bit lighter. Yeah. Of course, that is a super nice result. So this is cross belt only on the non-burr side of the 18 gauge stainless. So that is cross belt only 2 feet per minute, and that was white belt plus cross belt at 3 feet per minute, and that was cross belt only. That was slow at 2 feet per minute to get rid of that top burr. So here you have all the result. Everything is marked for you. And we will send that back. Again, my note, this is not perfectly deburred because we didn't run it through the white belt, just so that you can see what a cross belt by itself can do on a part like this. That was the 14 gauge stainless steel. Thank you.